Okay, I think this can be a decently quick video. So we have identifying similar transformations 7-6, a dilation that enlarges or reduces the original figure proportionally is a dilation. So a dilation isn't just when it gets smaller, it's also when the picture gets larger. And a dilation is a type of similarity transformation, meaning that it's still a similar shape. So it's basically the stuff we've been dealing with. Dilations are performed with respect to a fixed point called the center of dilation. And the scale factor of a dilation describes the extent of the dilation. So we're still dealing with scale factors. We'll get to how to do those in a little bit. There's two types of dilations. One is if the scale factor is greater than 1, that produces an enlargement. So like the picture, the green or the blue circle, triangle FGH, going to triangle RST. Obviously, it's bigger, has a scale factor larger than 1. In this case, it's 3. And a dilation with a scale factor between 0 and 1 produces a reduction, an image that is smaller than the original picture. And in this case, polygon ABCD is obviously small or bigger than polygon WXYZ. So now we're going to determine from A to B if it's an enlargement or reduction, and then find the scale factor. So if we're going from A to B, A is the blue one. Going to B, clearly A is larger, so we can say that this is a reduction. And now to figure out the scale factor, the first 3 examples we have are really easy because they're just straight lines, and we don't need to use the distance formula for straight lines. So if you take the points, so for A, we have 1 point, which is -3, 2. Here, let me circle it. We're taking this point and this point. So we have -3, 2 and 3, 2. And those are, they're obviously far away. It goes from -3, 6, sorry. Well, -3 to 3, that's 6 away. So for A is 6. And then for B, you take the points basically, it's the same points except in this case it's at negative, no, it doesn't go all the way, so it's -1.5, 1. And it's, again, here, let me circle them. That guy. And that guy, maybe you can do a better job circling, but who knows. And 1.5, 1. Oh, I spelled and wrong. And this is 3 away. So for the scale factor going from, in this case, A to B. So with A was 6, B was 3, so it's 6 over 3. So the scale factor is 2. That's not so bad, I think. And the next one, B. We have A to B this time. A is smaller, and we're going to B, so it's going to be an enlargement. So this is an enlargement. So we're going to take the points. In this case, we're going to take the vertical points. Basically, I'm just going to circle both these two and these two. So for A, the points for A are 3, 3 and 3, 0, which would be 3. So the distance is 3. And then you take the points on the other part, or B, the green line. So it's going to be 4, 4 to 4, 0. and that would be 4 away. And again, you can use the distance formula if you want, or the y is changed, so that's all that really matters, is 4. So we're going to take the scale factor. We're going to a to b, so that means it would be 4 over 3. Right? Oh no, a is 3. 3 over 4. Therefore, the scale factor is 4. So I guess I can write that up. Or 3 over 4. So I want you to try this one. You can do it. Try 1B, I mean. Way to go, kids. So the last one. This is one that you guys won't like, but if there are no vertical or horizontal lines, you do have to do the distance formula for every side. And then with every side, once you have them, use the distance formula to find the length of each side. And then you have to set up a long proportion. And basically, you have to do the two top parts, JK over PQ, has to equal KL over QR, equals the bottom parts ML and SR, divided by, which has to equal JM and PS. So you do that. And JK is 4. How do I write this? It's going to be 4 square root 10 divided by PQ is 2 square root 10. Equals, and if you wanted, you could keep doing this. I'm just going to do the first two because you're going to see a pattern. 2 square root 10 and QR is just square root of 10. And you would keep doing this, but you would notice that you would get 2 equals 2 equals 2 equals 2. Those are all the same. So we used the distance formula. We found that all the scale factors are the same, which means that we have found that these are, in fact, similarity transformations, and we've proved it, and we've done everything we can for that. So I hope you enjoyed the video.